Welcome to this discussion about outbreaks and investigation. In this video, I'd like to talk about some of the common environmental, health, behavioral, and other aspects of disease that predispose us to clusters or outbreaks occurring. And so here we're going to be talking about the host agent environment triangle, or the EPI triangle, and a lot of textbooks will refer to this because it's helpful to not just focus on the agent, or not just focus on the host, but to remember that all of these things in conjunction, kind of related to each other, is really what makes that disease happen. This kind of goes back to the whole idea of sufficient cause. Do we have enough of these things that are happening at the same time that we really have this particular outbreak or this cluster happening? So what I like to remember is that you have to get the agent to the host. The agent has to gain access to the host, in other words. The agent also has a certain relationship to the environment, and the host has a relationship then to the environment. So let's talk about the host really quickly and some of the common things about that can impact. So in terms of the host, there are often health factors that can impact, and there are also behavioral factors that can impact whether a person becomes infected. And so in terms of the host, in terms of the host's health, one of the big things worldwide is nutritional status. Those of you who are global health or nutrition majors know that if a person is undernourished, or even if they're overnourished, obesity can lead to a decrease in the immune system functioning. And so because of that, it just makes that person much more susceptible if they have the same exposure to the agent in that particular environment. If a person, for other reasons, has a decreased immune system, that can definitely impact their ability to resist that particular organism, sort of across the board. And so some things that can affect a person's immune system are chemotherapy, having a splenectomy, having certain other co-infections can cause a person's immune system, like HIV, to not be functioning properly. In terms of behavioral for the host, it really has a lot to do with what particular organism we're looking at. And so behaviorally, if a person habitually doesn't wash their hands, or even if they are not if they don't have good exercise or nutrition, if they're a smoker, those are some of the kinds of things that, so hand washing, kind of like that water sanitation and access to washing facilities, smoking. Obviously, a lot of times these overlap: exercise, nutrition. This nutrition overlaps with the nutritional status that they end up having, but it comes from a behavioral, like sometimes what they choose, sometimes it is just what's available to them, to being undernourished. So those are some of the host factors that can really impact. If those are factors that are related to a lot of the population, a high percentage of the population, then you'll end up with a population that's much more susceptible. In terms of the agent itself, for infectious disease, we're typically thinking about biologic agents. And specifically within biologic, we're thinking of infectious diseases, but there are other biologic agents that can lead to disease. And so under agents, I'm going to include some things that are not infectious disease, but hopefully that will help you see that this whole host agent environment triangle can be expanded to other non-infectious disease type things, even allergens or toxins that are found in the environment. Could be chemical agents You could have some kind of a sort of a chemical outbreak. One of the common ones is lead. Another common one is pesticides. You could have an outbreak of physical agents. And this depends sometimes on the workplace or things that people are exposed to in their neighborhoods. This could include things such as radiation, heat, cold, noise. And so you could have some kind of an outbreak related to those kinds of things. And then the other thing that's really important to think about, the agent itself could be a social or a psychological stressor. And we'll talk more about that when we get to the environment, because a lot of times those social and psychological stressors come from environmental causes, but the agent itself can be the social or psychological stressor. So talking about the environment is important because it influences the probability and the circumstances where that host and agent interact. And so the environment is the thing that kind of mediates or makes it possible for that to happen. And so it could be things like restaurant sanitation, their cleanliness, could be road conditions like weather, if we're thinking about some of these physical, even trauma. So road conditions or weather makes it possible for the car and the person to have this event. It could be social or political or economic. Sometimes in cases of social unrest. Could even have to do with crowding. And so what that does is, like let's say in a college dormitory situation or in a nursing home, we have more people that are congregating together, so they kind of override that herd immunity to some degree, because the person who is infected is exposed to more people than they would normally be. And so these are all kinds of things in the environment that can impact whether that agent and host come in contact with each other. Now there's a fourth part of the epidemiologic triangle that many people consider to be part of the environment, and I'm going to draw it separately, and it's vectors. Specifically, we think about vectors as being insects or animals or arthropods, and they either harbor the pathogen or the agent, or they are able to take it from one place and transmit it to another, so from an infected person to a new host. And the important thing about vectors is, the reason that I like to draw it separately is that the reason that vectors are important is because of their relationship with the agent. Does the agent reproduce as part of its life cycle inside of the vector? The vector we have to think about in terms of where that, how the vector and the environment interact, and then also in terms of the host. How does the vector come in contact with the host? And so I'd like to use an example of malaria. And so for this example, the host is human. And there are all these factors that impact whether a person is much more susceptible to malaria or if they're less susceptible. All of the hand washing probably not quite so much, but to the effect that whether that particular person is susceptible to malaria. The agent is Plasmodium. And it has part of its life cycle inside of the Anopheles mosquito. So it has to be a specific kind of mosquito that typically is the vector for certain kinds of diseases. So we have this mosquito. It has the Plasmodium because it got Plasmodium from biting another person, and so then it takes that Plasmodium, and the next time that it bites a person, it allows some of that Plasmodium to go into the new person. So that's how that can reproduce. The mosquito also has an interesting relationship to the environment, because the environment really needs to enable the mosquito to breed and to come in contact with the human. And so if the mosquito lives so far out in the moon tules that there aren't any people around, then it can't really spread that disease from one human to another. And so usually we have a warm climate. Often the mosquito bites at night. There needs to be standing water where the mosquito can lay its little larvae, and so the mosquito itself can reproduce. And there needs to be this ability then for the mosquito to come in contact with the host, and that's where we try to do things where we protect the host by providing bed nets or those kinds of things. So that's an example of outbreaks and the kinds of things that we think about in terms of what contributes to those. The common things that are associated with clusters or outbreaks occurring, these congregate settings, immunocompromised populations, even drug abuse within a person can compromise their immune system, and aspects of the disease that can predispose to outbreak development. That whole idea of the subclinical phase, where a person doesn't seem like they're sick, but and some people never go out of that, but the high infectivity rate and the ability for the host and the agent to come in contact being mediated by the environmental factors. The last thing that I want to talk about is one thing that has to do with outbreak investigation, and that has to do with defining a case. And this, remember how I talked about how it can be really difficult to put absolute numbers on them, and the reason is because a case definition often becomes the way that you, or always becomes the way that you identify how many people you're dealing with. And because people have such a wide variety of presentations, that case definition needs to be somewhat inclusive. So a lot of times for a case definition, it will include such things as they had a rash and or they had a cough. And a lot of times we'll try to verify whether that person with those particular signs and symptoms had the disease by drawing blood or taking a throat culture or some other kind of measurement that we can send to the lab and say, yes, this person had the disease that we're interested in understanding, rather than they just had something else that had some of the same symptoms. Because you can imagine there are a lot of diseases that cause a cough, but not every time a person has a cough do they have that particular outbreak that you're interested in that community. They could be coughing for some other reason. So formulating a case definition is one of the really important pieces of an outbreak investigation. So just keeping that in mind. So thank you for joining me for this video.